In the vast expanse of our universe, amidst the brilliance of countless stars, lies a celestial titan that has captivated astronomers and sky watchers for centuries, Betelgeuse. This enormous red supergiant, burning bright in the shoulder of the constellation Orion, has recently made headlines not for its familiar fiery glow, but for a dramatic cosmic event, a massive surface mass ejection that shook even seasoned scientists. But to understand the magnitude of what happened, and what it might mean for the future of Betelgeuse, and perhaps even our own cosmic neighborhood, we need to journey deep into the life and inner workings of this enigmatic star. Betelgeuse, often pronounced as either Betelgeuse or Betelgeuse, is one of the most well-known stars in the night sky, partly because of its reddish hue and partly because it's a star nearing the end of its life. Located roughly 642 light-years away from Earth, this giant has long fascinated astronomers not only due to its brightness but also because of its sheer size. If Betelgeuse were placed at the center of our solar system, it would engulf Mercury, Venus, Earth, Mars, and possibly even Jupiter. That's a diameter of over 1.2 billion kilometers, about 1,000 times the size of our Sun. Yet, despite its immense size, Betelgeuse's mass is only around 10 to 20 times that of the Sun. That might seem counterintuitive at first, but it's a result of its evolutionary stage. Betelgeuse is a red supergiant, a phase that marks the final act in the life of a massive star. It has exhausted the hydrogen fuel in its core and is now fusing heavier elements like helium, carbon, and oxygen. This phase is unstable and turbulent. The star swells in size, cools on the surface, and becomes increasingly prone to dramatic outbursts, and that's exactly what happened recently. In 2019, astronomers noticed something strange. Betelgeuse, normally among the top 10 brightest stars in the sky, began to dim. Not just a little dimmer, it lost nearly 2/3 of its brightness over just a few months. By early 2020, the star looked visibly different even to amateur astronomers with telescopes. This event, dubbed the Great Dimming, sparked intense speculation. Was Betelgeuse about to go supernova? The idea was not entirely far-fetched. Massive stars like Betelgeuse don't live very long, typically only a few million years compared to the Sun's comfortable 10 billion-year lifespan. And when they die, they do so in spectacular fashion, collapsing under their own gravity and rebounding in a violent explosion known as a supernova. Such an event would be bright enough to outshine the full moon, visible in the daytime sky for weeks, and it would dramatically reshape the immediate cosmic environment around the star. But as the weeks turned into months, Betelgeuse slowly regained its brightness. The supernova didn't happen. And astronomers were left with a mystery: what had caused the Great Dimming? Then came the breakthrough. Using observations from NASA's Hubble Space Telescope and other instruments, scientists discovered that the dimming wasn't due to any internal collapse or core activity. Instead, Betelgeuse had undergone an unprecedented surface mass ejection, a colossal expulsion of matter from its outer layers. The ejected material cooled and condensed into a cloud of dust that temporarily blocked the star's light from our vantage point on Earth. To put this event into perspective, the amount of material expelled was several 100 billion times the mass of the Earth's atmosphere. It's something astronomers had never seen before on a star outside our solar system. While the Sun routinely undergoes coronal mass ejections, violent eruptions that can interfere with satellites and power grids here on Earth, this was on an entirely different scale. Betelgeuse didn't just spit out a flare. It coughed up a massive chunk of its own atmosphere. The implications of this event are profound. For one, it gives us a rare and valuable window into the end-of-life processes of massive stars. Scientists believe this surface mass ejection could be linked to deep internal changes within Betelgeuse, perhaps indicating that the star is entering the final stages before it eventually goes supernova. However, estimating the exact timing of such an event is notoriously difficult. In cosmic terms, Betelgeuse could explode tomorrow, or in 100,000 years. But what would happen if Betelgeuse did go supernova in our lifetime? First, let's be clear, we would not be in danger. At over 600 light-years away, Betelgeuse is far enough that the harmful radiation from the explosion would dissipate long before reaching Earth. But visually, the event would be spectacular. For weeks, possibly months, a new star would dominate our skies, outshining even Venus and perhaps casting shadows at night. It would be visible during the day and would become a centerpiece of skywatching across the globe. Then, slowly, it would fade. What remained would be the collapsed core of Betelgeuse, possibly a neutron star or even a black hole, depending on how the collapse unfolds. The outer layers of the star, meanwhile, would be hurled into space, enriching the surrounding interstellar medium with heavy elements like iron, calcium, and oxygen, the building blocks of planets and life. In fact, it's worth pausing here to reflect on this process. Every atom of calcium in your bones, every molecule of iron in your blood, was forged in the heart of a dying star, in a supernova not unlike what Betelgeuse is destined to become. Stars like Betelgeuse are not just beacons in the night sky. They are factories of creation, seeding the cosmos with the raw materials for future worlds and, eventually, life itself. Back to the present, how do we study a star like Betelgeuse in such detail, especially when it's hundreds of light-years away? Astronomers use a suite of advanced tools and techniques. One of the most valuable instruments has been the Hubble Space Telescope, which provided early warning of the 2019 mass ejection by detecting changes in ultraviolet light from the star. Ground-based observatories, including those using adaptive optics to cancel out the blur of Earth's atmosphere, have also been critical. These technologies have enabled scientists to capture actual images of Betelgeuse's surface, an extraordinary feat in itself. More recently, space observatories like NASA's James Webb Space Telescope have added new dimensions to our understanding. By observing in infrared wavelengths, Webb can peer through dust clouds that would otherwise obscure our view. This is especially important for Betelgeuse, whose recent outburst has surrounded it in a thick veil of dust. With these tools, scientists are monitoring the star's atmosphere, watching for signs of instability, and trying to model its internal structure in unprecedented detail. But it's not just about Betelgeuse. Understanding what's happening to this one star can help us better grasp the broader life cycle of massive stars across the universe. It informs our theories about how galaxies evolve, how elements are distributed through space, and how environments for potential life are shaped. In the case of Betelgeuse, recent studies suggest that its internal structure may be more complex than previously thought. There are hints that it's rotating more slowly than models predicted, and that it may have undergone mergers or interactions with other stars earlier in its history. These complications make it harder to predict its exact timeline, but they also make it more fascinating. Betelgeuse may be teaching us that the late stages of stellar evolution are far less orderly than we imagined. It's also possible that the surface mass ejection was not a one-time event. In fact, astronomers are now watching closely for similar outbursts. If Betelgeuse continues shedding mass in this way, it could be a sign of increasing instability, a prelude to the final collapse. Yet for all we know, Betelgeuse may still have centuries, or longer, left. Massive stars can experience fits and flares for thousands of years before they finally give out. And that leaves us in a strange position, watching, waiting, and wondering. We know a cosmic drama is unfolding. We just don't know which act we're in. Still, there's something profoundly human about our relationship with Betelgeuse. This star has been observed for thousands of years. Ancient civilizations wove it into their mythologies. To the Egyptians, it may have helped mark the solstices. To the Greeks, it was the shoulder of Orion, the great hunter. To the Japanese, it was part of the constellation known as the Drum Star. Today, it's a testbed for cutting-edge astrophysics and a source of wonder for anyone who looks up on a cold winter night. And perhaps that's the most important lesson Betelgeuse offers us. In a universe that often feels vast and impersonal, this star reminds us that we are part of something much larger. Its life and death will shape the cosmos in ways we are only beginning to understand. And whether it explodes tomorrow or 10 millennia from now, we will continue watching, learning, and dreaming, just as we always have. So the next time you gaze up at Orion, and you spot that bright red star twinkling in his shoulder, take a moment to appreciate the cosmic titan that is Betelgeuse. A star in its twilight, a giant nearing its end, and a glimpse into the epic forces that shape our universe. Because in the grand tapestry of space, Betelgeuse is not just a star. It's a story still unfolding, one burst of stardust at a time.